on this 2019 to 2025 Chevrolet Silverado 1500. With the 5.3 gas engine, P0325 points us toward the knock sensor circuit. In plain language, the engine computer may not be seeing the knock sensor signal the way it expects. The truck may have a check engine light, and because the system can retard ignition timing to protect the engine from knock, it may feel down on power or less responsive. The broad fault areas can include the knock sensor itself, its mounting and condition, the connector or wiring between the sensor and the engine control module, possible engine mechanical or accessory noise, and fuel or fuel pressure conditions that can affect knock behavior. We're going to keep this focused on P0325 and use the related knock system codes only as context. Before getting deep into the circuit, start with the basic system checks, then follow a structured diagnostic approach. Make sure you understand whether this is a current fault, an intermittent, or something that only showed up under a captured operating condition. If other codes are present, check what they mean first, because that can change the direction of the test path. With the engine running, first verify whether P0325 is setting along with the knock sensor circuit group or the control module knock sensor processor group. If P0325 is the active direction, move into the circuit testing path. If the control module processor direction is the only thing setting, the diagnostic path points at the engine control module instead. If those codes are not set at that moment, watch the scan tool parameter for cylinder 1 to 8 knock detected. The expected state is no. While watching that parameter, wiggle the knock sensor harness and connector, then the engine control module harness and connector. If the parameter changes from the expected state, repair the wiring, terminals, or connectors as needed. This is the intermittent check before you start condemning parts. If the scan data is in the expected state, then make sure the related knock performance direction is not active. If that direction is active, inspect the knock sensor for installation problems, outside interference, and visible damage. Also look at nearby brackets, the accessory drive, belt-driven components, basic engine mechanical condition, fuel quality, and fuel pressure conditions. If you find a condition there, repair it as necessary. If those checks are normal, the path moves toward testing or replacing the knock sensor. If none of the codes are setting during verification, operate the vehicle within the monitor gates for P0325, or reproduce the captured conditions from the stored data. Do not turn that running condition list into a parts call. Use it to make the monitor run. The diagnostic formulas matter here too. An open signal circuit for greater than 5 seconds can set this direction, and the related signal circuit checks also use greater than 5 seconds for short to ground and greater than 5 seconds for short to voltage. Then verify the DTC does not reset. If it stays gone, the check is okay at that time. If P0325 resets, go to circuit testing. For the circuit test, turn the ignition and vehicle off, then disconnect the knock sensor connector. Turn the ignition on with the vehicle in service mode. At this point, you are checking what the control module and harness are providing on the two knock sensor signal circuits. The control module input for terminal 1A has internal resistance connected to 1.33V, and terminal 2B has internal resistance connected to 5V. So the two circuits do not use the same expected voltage window. Test between signal circuit terminal 1A and ground. The expected reading is 1 to 2V. If it is less than 1V, turn the ignition and vehicle off, disconnect the engine control module connector, and test that circuit to ground for infinite resistance. Less than infinite resistance means repair the short to ground. If it is infinite resistance, check continuity end to end. The expected result is less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the path points to replacing the engine control module. If terminal 1A is greater than 2V, disconnect the engine control module, turn the ignition on in service mode, and check that circuit to ground for less than 1V. If it is 1V or greater, repair the short to voltage. If it is less than 1V, the path points to replacing the engine control module. If terminal 1A is in the 1 to 2V window, move to signal circuit terminal 2B. Test between terminal 2B and ground. The expected reading is 2 to 4V. If it is less than 2V, Turn the ignition and vehicle off, disconnect the engine control module connector, and test that circuit to ground for infinite resistance. Less than infinite resistance means repair the short to ground. If it is infinite resistance, check continuity end to end. The expected result is less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the path points to replacing the engine control module. If terminal 2B is greater than 4V, disconnect the engine control module, turn the ignition on in service mode, and check that circuit to ground for less than 1V. If it is 1V or greater, repair the short to voltage. If it is less than 1V, the path points to replacing the engine control module. If terminal 2B is between 2 and 4V, the circuit side has passed this part of the test, so move toward testing or replacing the knock sensor. For component testing, turn the ignition and vehicle off and disconnect the knock sensor connector. Test resistance between signal circuit terminal 1A and signal circuit terminal 2B. The expected result is infinite resistance. If it is less than infinite resistance, replace the knock sensor. If that test passes, test from each terminal of the sensor to the sensor housing. That result should also be infinite resistance. If either terminal is less than infinite resistance to the housing, replace the knock sensor. If both checks are infinite resistance, the component test is okay. After any repair, keep verification separate from the testing that found the fault. Verify the repair and confirm P0325 stays gone. The takeaway is simple. On P0325, do not jump straight to the sensor. Prove the scan data, stress the harness, inspect the sensor and surrounding conditions, then test both signal circuits before making the call. For more diagnostic training, visit stepdiagnostics.com.